In this video, I want to have a look at solving single variable trig equations. Now, we have had a look at this in 2-unit mathematics, but in this video, I want to have a look at some harder applications of that same sort of process. So our first example asks us to solve the equation sine 2 theta equals a half for theta between 0 and 2 pi. Now, the first thing we're going to do is we're going to replace this 2 theta just with an x for now. So we're going to write let x equal 2 theta. And that's going to mean that our equation is going to become sine of x equals a half. Now, if we change this 2 theta to an x, that's also going to change our domain. Because this, if we had a 2 theta in there instead, we'd have to multiply both the ends of our domain by 2 as well. So that would be 0 and 4 pi. So for this equation here, we're going to have x between 0 and 4 pi. Now, when we solve this, we can draw up our all stations to central diagram. We know that sine is positive, so that's in this quadrant or this one. And from our special triangles, we know that our related angle is going to be pi on 6. So that's 30 degrees. Now, because we're going between 0 and 4 pi, we're going to have to do 2 whole revolutions around that diagram. So that's going to give us 4 solutions for x. We're going to have x equals pi on 6. For this one here. For this one, we'd end up with 5 pi on 6. And now we have to go all the way around that diagram again. So this here would be 12 pi on 6. This would be 13 pi on 6. And then if that's 12, that's 18. So this one back here would be 17 pi on 6. Now that's x though. So that means that that's 2 theta is equal to those, which means that theta is going to be equal to pi on 12, 5 pi on 12, 13 pi on 12, and 17 pi on 12. And that brings all of those answers back into our original domain. Our second example asks us to solve cos of 2x minus pi on 6 equals root 3 on 2 in the domain 0 to pi. So we're going to start in a similar sort of way. We're going to let this time, let's call it theta, because we've already got an x up here. So let's say let theta equal our 2x minus pi on 6. So it's going to simplify our equation down to cos theta equals root 3 on 2. But again, it's going to change our domain. Now, to change our domain to 2x minus pi on 6 in the middle, we're going to have to multiply everything by 2 and then subtract pi on 6. So to get 2x in there, we'd still have 0, but we'd have 2 pi up here. And then to get 2x minus pi on 6, we'd have to subtract pi on 6 from both of our upper and lower bounds as well. So our domain now is between minus pi on 6, and this would be equivalent to 12 pi on 6. So we'd end up with 11 pi on 6. So now we can solve this. Again, we'll draw up our all stations to central diagram. Our cos is positive, so that's this quadrant and this quadrant. And again, from our special triangles and our exact values, our related angle is going to be pi on 6 again. So now remember though that we're starting our domain at minus pi on 6. So our domain actually starts here and goes all the way around back to this value here. So that means that our first value of theta, our first solution, is going to be minus pi on 6. And then we're going to come up this way till we get to pi on 6. And then we're going to come all the way around back to this line. So because of those less than or equal to signs, it can be on the boundary as well. So that's going to be 11 pi on 6. Now again, that's what 2x minus pi on 6 is equal to, all of those things. So we'll just rewrite them for a second. And then we're going to have to solve that equation. So I'm going to add pi on 6 to both of them. So I'm going to get 2x equals 0, 2 pi on 6, and 12 pi on 6. And then I'm going to divide them all by 2. So I'm going to end up with x equals 0. Now, if I divide this by 2, I'll end up with pi on 6. And this one, I'll just end up with pi. So within that original domain, we have 3 solutions. We have 0, pi on 6, and pi. Our last example is actually an inequality instead of an equation this time. So it asks us to find the values of x for which cos 2x is less than or equal to 1 over root 2 in the domain 0 is less than x is less than 2 pi. So to do this, we're actually going to look at the equation first of cos 2x is equal to 1 over root 2. We're going to solve that, and then we can use those values and a sketch to help us answer the inequality. So to solve this, we're going to let theta equal 2x, and it changes our equation to cos theta equals 1 on root 2. And again, that's going to change our domain to 0 is less than or equal to theta is less than or equal to 4 pi. And then we can solve that. If we draw our diagram, all stations to central, cos is positive here and here, and our related angle from our special triangles is going to be pi on 4. So that means our answers for theta are going to be pi on 4. And if we come all the way around, that would be 7 pi on 4, and we've got to do 2 revolutions. So this one's going to be 9 pi on 4, and 15 pi on 4. Okay, but that's theta, and we know that theta is 2x. So if we want to find x, we're going to have to divide each of these by 2. So we're going to have x equals pi on 8, 7 pi on 8, 9 pi on 8, and 15 pi on 8. All right, so that solved this equation, but we want to know when cos 2x is less than or equal to 1 on root 2, not just equal to it. So to do that, we're going to have to draw a sketch of cos 2x to help us. Now we're going to draw it between 0 and 2 pi. So draw 2 pi here. Pi would be halfway. Now if we just had cos x, it would start at 1, come down to -1 at pi, and then back up to 1 at 2 pi. But that 2x in there means it's actually going to change the period of this cos wave, and it's going to fit twice in that domain. So it's going to meet -1 at pi on 2, 3 pi on 2. So it's going to start at 1, it's going to come down, it's going to come down here to -1 and back up to 1, and then do the same thing again. All right, so we know that this curve is going to be at a value of 1 on root 2. So if we put that, say, about here, just for clarity, we can see that if we looking when the curve is at that value, it's going to have that value 4 times. And those 4 values that we found are these. So this one's at pi on 8. This one's 7 pi on 8. This one's 9 pi on 8, and this one is 15 pi on 8. So we want to know when our curve is below 1 on root 2, so less than. So that's going to be this section of the curve and this section of the curve. So our x value is going to have 2 regions that make that inequality true. So we're going to have x is greater than or equal to pi on 8, but less than or equal to 7 pi on 8, so that's this dip here. And then we're going to have this one up here as well. So we're going to have 9 pi on 8 is less than or equal to x is less than or equal to 15 pi on 8. So those are our solutions that make that inequality true in that domain. All right, so that's having a look at solving 3-unit problems involving trig equations with single variables.